Hello, my name is Hikaru Fujita from the University of Tokyo, and today I will present my work titled Presenting Tingling After Effects using Vibro-Thermal Feedback to Enhance Impact Sensation in Virtual Reality. In VR, the impact sensation, defined as a feeling that occurs when an object or body is struck forcefully, is essential. This sensation not only enhances the immersive quality in entertainment applications like baseball games, but it can also improve training and educational outcomes by making experiences feel more realistic. There's a demand to present strong impacts on the body to enhance realism. Many studies have addressed how to recreate impact sensation in VR. A notable recent trend is to decompose the physical phenomena at the moment of impact into multiple modalities, such as contact sensation and force feedback, and present each component with separate actuators. However, device costs and safety concerns can limit the intensity and realism of simulated impacts. In our research, we take a novel approach by splitting the impact sensation into two parts. First is the sensation at the moment of collision, and second is the sensation of after effects, which can be defined as various sensations that emerge within the body following the physical stimulus. For example, the tingling felt in the hand after hitting a ball with a bat is an after effect. While existing methods focus solely on the collision, our aim is to present these after effects to make the overall experience stronger and more realistic. For our experiment, we use a baseball hitting experience as a case study. Our objective is verify that presenting tingling after effects can enhance impact sensation without increasing the physical intensity of the stimulus. We hypothesize that presenting tingling after effects can enhance the realism and perceived intensity of impact sensation, and tingling sensation can be presented using vibro-thermal feedback. To test these hypotheses, we designed haptic feedback replicating impact sensation, including the tingling. As mentioned, we first broke down the overall impact sensation into collision sensation and after effects sensation. The collision sensation, which is the immediate sensation when the bat hits a ball, is reproduced using existing methods. Our contribution is in the after effects, the tingling sensation emerging within the body after the collision. We further divide this tingling into two parts, a numbness sensation and a heat, burning pain-like sensation, each of which we think can be presented by vibrotactile and thermal feedback. I won't go into every technical detail today. Instead, here's an overview. This diagram summarizes our haptic feedback design. First, we replicate the collision sensation with vibration and impulsive force. Then, we present the tingling after effects using vibro-thermal feedback. Our preliminary evaluations show that 500 Hz vibrations effectively induced numbness, while 50 Hz was less effective. Thereby, our user study mentioned later, including those two frequencies. In addition, thermal feedback was set to a 3 degrees Celsius increase based on established thresholds and previous VR studies. And we developed a bat-like device capable of delivering the designed haptic stimuli. It integrates a voice coil actuator, solenoid actuator, LTA element, and a VR tracker. When you swing this device, the bat in the virtual environment moves correspondingly, ensuring that the haptic feedback is synchronized with the visual feedback. Now let's move on to the user studies. Participants were asked to perform a task to hit a ball with a bat in a virtual environment. The procedure involved two tasks, a reference task without After Effects feedback and an evaluation task with After Effects feedback. Participants compared the sensations from the evaluation task against the reference task using a magnitude estimation method, where the reference task is 100 as a baseline. We evaluated three aspects: the intensity of tingling sensation, the realism of impact sensation, and the perceived intensity of impact. For the evaluation task, we created 6 conditions. We evaluated the vibration with 3 conditions: no vibration, 50 Hz, hereafter as low frequency, and 500 Hz, high frequency, and the thermal feedback with 2 settings, with or without, making a total of 6 After Effects conditions. Note that the collision feedback remained constant across all conditions. Let's now look at the experimental results. Regarding the first evaluation item, the tingling sensation, we found significant main effects for both the vibrotactile and thermal stimuli. Post hoc tests showed significant differences across all combinations. In short, both vibrotactile and thermal feedback effectively presented a tingling sensation, with high-frequency vibrations producing a stronger effect than low-frequency. When we examined the realism of impact, only the vibrotactile stimulus had a significant effect. All combinations of vibro factors showed significant differences, with high-frequency vibration enhanced realism more than low-frequency. This finding suggests that the specific quality of the tingling presentation is a key to the enhanced realism, rather than merely adding more sensory information. Finally, for the perceived intensity of impact, both vibrotactile and thermal feedback produced significant effects, but there was no significant difference between low and high-frequency vibration, suggesting that the perceived intensity is more strongly related to the presence of after effects than to vibration frequency alone. I'd like to share some insights from our post-questionnaire. Participants' free responses were largely focused on the thermal feedback. Some noted that the combination of heat and numbness made the sensation feel stronger, while others mentioned that heat alone felt odd, or that excessive heat made the sensation seem artificial. These comments indicate that while our combined biothermal approach is effective, there is still room for optimizing the thermal parameters. To sum up, our results confirm both of our hypotheses. First, presenting tingling after effects enhance their realism and perceived intensity of impact sensation without increasing the physical stimulus intensity. Second, our vibro-thermal feedback method effectively induces a tingling sensation. We also observed that high-frequency vibration is especially effective at inducing numbness and enhancing realism. For future work, we plan to refine the thermal feedback parameters to better account for individual differences. We also intend to explore extending the after effects feedback to other intense sensations, such as heat, force, or pain, to create even more immersive VR experiences. That's all for the presentation. Thank you very much.